Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous few lectures we have been covering Python language mainly in the context how basics and how it could be really useful in the analytics context. So, from the analytics perspective we have been covering Python. Now, in the previous lecture we started our discussion on functions. So, let us pick up from there. So, we talked about functions. So, functions are just any other type of Python objects. However, as we discussed that they are one of the most important mechanisms in terms of code organization and reuse, because many times if certain piece of code we would like to execute again and again for certain computations, certain other processing that we require. So, it is better to have them in the functional form. So, we can use these functional objects, functional Python objects. So, in a sense we would be able to reuse that part of the code and our code organization would also improve. So, for any programming languages, functions play an important role. Now, as far as Python is concerned, in terms of defining function objects, we declare them with using a def keyword, and typically they might have more than one a return statement. So, as you can see here dead end kind of statements. So, as we have discussed in the previous lecture that your flow of execution can go to any of the multiple paths that could be there, and in each of paths that are possible we are supposed to have return statement, so that we are able to end the code of execution in the functional scope and able to return to the parent scope. So, for that we need those return statements to indicate the same, and in case no return statement is encountered, none is returned automatically. So, this is about how we are supposed to structure our function objects in Python. Now, as we have discussed in the previous lecture, they can have positional arguments as well as keyword arguments, and for obvious reason keyword arguments must follow the positional arguments, because the positional arguments they are to be accessed by their positions. However, keyword arguments they can also be accessed by their names, the keywords. So, therefore, first positional arguments and then keyword arguments will follow them. So, that is the typical structure. One example that you can see here, this part of the code you can see we have we are defining a function f, and 3 arguments are there x, y and z, and the first 2 arguments are positional argument, third argument is the keyword argument, where we have given a value also. So, typically as we have discussed before as well, keyword arguments they are typically used when we would like to have a default value. So, and the nature of keyword arguments also facilitates different ways of calling that particular function. So, we will go through this. So, in the code block of this functional object, what we have conditional logic here, if else blocks here. So, if z greater than 1, then we will return this expression, and otherwise else will return this expression z divided by x plus y, or if z greater than 1, then z into x plus y. Now, we can call in many ways, we can call this function in many ways. So, first example that we are taking here is f first argument is 1, second argument is 2, and then third argument z is equal to 0.3. Remember it the third argument is the keyword argument is also having a default value as well. So, if I run this, so you can see we obtain a value here, and then similarly second way of calling would be we just pass the values. So, f then 3 comma 4.5 comma 1.3. So, if I run this I will get a value. Then another way of calling is that we are just passing values for first 2 arguments, and the third argument is in a sense optional argument, because we have already indicated the default value in the definition itself. So, if we want, we do not need to specify that. So, therefore, we can call this function using just 2 arguments. So, if I run this, we will get a value. Now, this much we have discussed in the previous lecture as well. So, now let us move forward. Now, let us talk about some more aspects about functions, namespaces, scope and local functions. So, functions can access variables in two different scopes, one is global, one is local. So, a variable scope whether it is global or local, it is also referred as a namespace in Python terminology. So, a local namespace within a function, it is typically created when a function is called and it is destroyed after the function is finished. When we are in the functional environment, when we are executing the code within function, then a local namespace for that functional scope is created, and once the call to that function is finished, then that local namespace is destroyed. So, all the variables that would be created inside the functional scope inside that local namespace, they would be destroyed once the execution comes out of the functional scope, the local namespace. So, let us understand this through few examples. So, here in the first example, what I have done, I have created a variable outside the functional scope v5, and this is an empty list here, and then I am defining a function called f1, and in that I have this just a for loop there for I in range 5 and v5 dot append I. So, we would be appending these elements one by one as we run the loop into the empty list that we have created. So, let us run this, and once the function is defined, you can see let us call this function f1. So, in this fashion f1 and the parenthesis, because this function does not require any argument. So, just empty parenthesis here, and we have called the function. Now, if we check the value of v5, so you would see that even though we have added elements in this v5 list inside the functional scope, but since v5 was defined in the global namespace, therefore, the values have been added to this variable, and you would see in the output that 0, 1, 2, 3, 4, all the elements that we have added inside the functional scope inside the local namespace of the function, they can be accessed, they can be seen in the global namespace as well, because the variable was defined and created in the global namespace. So, it will not be destroyed once we come out of the functional local namespace of the function. So, that is one aspect. Now, let us remove this variable. So, we can use the del command here and del v5. So, let us remove this one. Now, we are defining another function here to again understand the namespace and the scope aspects. So, here in this function, the v5 variable is defined in the functional scope itself, in the local namespace of the function itself. So, def f2, and the first line is the one where we are defining this variable, creating this variable v5 empty list, and then we are running the loop for I in range 5, and you can see then we are appending the element to this particular sequence, this particular list. So, in this case, this variable v5, this list object v5 has been created in the functional scope or local namespace of the function. So, therefore, once the call to that function is finished, then this particular variable is going to be destroyed. So, if we try to access this particular variable or its elements, we will not be able to do so. So, let us run this, let us define the function f2, let us call this function, and once we are able to call this function, and let us try to access this variable v5. So, you can see name v5 is not defined. So, because once we call the function, that local namespace gets destroyed. So, along with that, any variable, any other objects that are part of that local namespace, they would also get destroyed. So, v5 is destroyed in that sense, and therefore, we cannot see the elements of v5, we are not able to access, because as far as global namespace is concerned, the global scope is concerned or the parent scope is concerned, this variable does not exist, this variable is not defined. Now, let us understand few more aspects about scope, local and global scope. Now, sometimes we might like to create a variable within the function, but with global scope. So, that is also possible. For that we can use global keyword. So, what we can do is, you can see in this example here. So, we are defining a new function f3 here with no arguments. So, to define a variable inside the body of the function, but with global scope, we need to use global keyword. So, the variable we are defining global v5. Once we have defined the type of the scope of this variable, then we again initialize it as an empty list v5 as an empty list, and then we run the loop. So, because we have used the global keyword, or we have in a sense defined this variable in the global namespace or the parent scope. So, therefore, if we call this function and in the code block of the function elements are being added. So, we would be able to access even the once the call to the function is finished. So, if I run this, the function will be defined. Now, if I call this function f3 here, so call has happened. Now, if I try to access this variable v5, you can see 0 1 2 3 4. Now, because the function was defined using global keyword. So, therefore, it is in the global part of the global namespace. So, therefore, even though we added the elements inside the local namespace of the function, we are able to access this particular element because it is in the global namespace. So, this is about the a local and global scope and the namespace aspects in the Python language. Now, let us move forward. Now, let us talk about some different aspects about functions. So, some of these things we have touched upon before as well. For example, returning multiple values. So, this aspect also we have discussed before. So, let us do one more exercise here while we are discussing functions in more detail. So, I am defining another function def f4 parentheses no arguments here, and in the body of the function I am creating these variables a equal to 5, b equal to 6, c equal to 7, and I am returning a comma b comma c. So, you can see when we return in this fashion, in a sense we are returning a tuple here. So, using the tuple data structure that we have in Python language, we are able to return all these values in one go, and you can see in the next line of this code block, I am recording this returned value from f4 by calling f4 and storing in the this tuple abc outside the functional namespace. So, if I run this, so here you can see first thing that you should notice that ABC that were created inside the functional scope in the local namespace of the function, they will be destroyed. The the ABC that we will access, they are the new ABCs that we have created in the global namespace by recording the return value of the function f4. So, if I try to access the value individual element of this tuple. So, if I try to access, if I run this b, you can see we got the value 6. So, you can see in this fashion we can return multiple values and then access them in the global namespace as well. Now, another way to do the same thing is I can record this variable instead of tuple with instead of mentioning each element of the tuple, I can just record this value, store this value in a variable v6. So, it is stored. Now, if I access this variable v6, you can see we got a tuple here 5 6 7. So, this is another way to perform the same thing. Now, instead of mentioning the elements of the tuple, we can have the tuple variable, and whenever you want to access, we will get the tuple as the output. Now, the same kind of thing we can also do with the dict data structure. So, let us do the same exercise again once more. So, again we are defining another function def f4, and you can see again 3 variables a equal to 5, b equal to 6, c equal to 7. Now, we are returning in the dict format. So, the dict format is about key value pair combination. So, you can see a is the key and then colon A, then B, and colon B, C, colon C, and in this format we would be returning the value that we have created in the functional scope. So, then I am recording the return value by calling this function f4 in a variable v7. So, if I run this part of the code and if I access this value v7, this variable, you can see we have got a dict object here. Now, with the values of those elements value part of those key value pairs as well in that dict object. If I look at the type of f4, because we have discussed that the functions in Python are also objects. So, if I look at the type of f4, so you can see function is the output. So, here these are function, type of these objects is function here. Now, let us move forward. Now, we would like to discuss a particular scenario so we can all the time, as we discussed writing lines of code which could be repeated later on. So, as we discussed, we can use functions to make them to organize that part of the code and reuse that part of the code. So, so that is one thing, but another aspect is writing functional in such a way that they are more generic and more reusable. So, the same function we can write in a fashion that it can be used in only one particular situation, but the same function the same lines of code, same code block, we can reorganize that code of block into more than one functions or in some fashion, so that it can be used in more than one scenarios. So, there can be those situations where the same code block can be written in the form of function, can be used in very few scenarios, and the same code block can be written in the form of one or more functions and can be used in many scenarios. So, that aspect also I would like to emphasize here. So, this is about writing more reusable and generic functions. So, one example that we are taking here is data cleaning on a list of strings. So, when we talk about data cleaning, it is about stripping white spaces, removing punctuation and proper capitalization, consistent capitalization that we might require typically in the analytics context. So, let us talk about the first approach, which is not that much reusable and generic, but nevertheless we are using function here itself. Then we will take the second approach, which is slightly more reusable and more generic in nature. So, let us start. So, in this first approach, we are using built-in string methods along with the RE standard library module for regular expression. So, in this we have this example, we have this messy strings. So, this is a list, this is a sequence, this is a list object and having string elements, and the strings, if you see Alabama, it has a white space before it and the white space after the characters that are part of Alabama, and then Georgia we have extra exclamation marks, and capitalization is also not consistent. We have Georgia multiple times with different variations, and Florida, South Carolina with extra hash characters there. So, this is the kind of a string that we have. So, this is the messy string that we have. We would like to clean this particular data, clean this particular sequence of string values. So, for that we would like to because this is something that cleaning of a particular string we might require quite often. So, why not write a function to perform this task, because that would be that would lead to better code organization, better reuse of the code. So, we are importing this module because we would be using certain functions which are part of this module RE, and then we are writing a function called clean underscore strings. So, our objective is to deal with such kind of strings, to be able to strip them of white spaces, punctuation symbols and capitalization. We would like to have consistent capitalization. So, in this code block of the function we are first defining the result, the empty list that is there, and because in this empty list we would like to return the cleaned string. Once we have performed all our cleaning operation, we would like to return that cleaned strings using this result object, result variable. So, we are running a loop here. So, for x in strings, So, this strings is a list of string element. So, for each of the string we would like to run the loop, and we would like to perform certain operation in each of the string element here. So, first thing we are doing is we are calling this function x dot for each string we will call this strip function. So, what it will do is it will remove all the white spaces that are part of a particular string. So, all the white spaces trailing or otherwise they would be stripped off. Then in the next line of code we are calling this function as part of this module re dot sub. So, this will again substitute if there are any punctuation mark or any characters they would be substituted. So, you can see in the first argument that we are using here we have these within the this list that we have exclamation, hash, question mark. So, these are some of the punctuation marks or some special characters. So, we would like to substitute them with the this character a null character here. So, this is something that we would like to perform to get rid of the punctuation symbols. Then next thing is x dot title. So, we are calling this title method here. So, in this all the string that we have they would be converted into the title format. So, in a sense they would be in the consistent the capitalization would be consistent in as per the title format. So, let us define this. Now, the function is created. Now, let us look at the message string that we have now. Run this. So, you can see this list message string that we have, and you can see the problem with the string values and the cleaning that might be required. Now, we will call the function clean strings that we have just defined here. If I call this function, you can see clean string, I am passing this string in this as an argument, and you can see the whole string has been cleaned. Now, you can see Alabama, Georgia, Georgia and Georgia, all the string elements that we have, only the first letter is capitalized for all of them, and any extra spaces that we had they are gone, and any punctuation symbols or special characters that we had they are also gone. So, in this first approach what we had done we have defined a function, and in the code of that function we have done certain number of operations in one go in a for a particular list of strings. So, this is one approach. Now, can we write a function in slightly more reusable and slightly more organized way, so that it is more generic. So, it could be used in multiple scenarios. So, let us focus on the second approach. So, what we are doing here is what we are trying to achieve here is we will apply a list of the operations on a list of strings. So, instead of in the first approach in the function we just kept applying operations. Here we are trying to further identify another structure like we have a list of operations that we want to perform on a list of strings. So, in that sense we will create a list of operations that we would like to do, and we would like to apply that on the list of strings. So, we will create two different functions here. So, first function is about remove punctuation. So, in this we are just using that re dot sub function here, and any punctuation mark or a special character they would be removed by calling this function. Now, we are focusing on the list of function based operations to be applied. So, it could be user defined or built in. So, in this we have created a list of operations, list of function based operations. So, you can see first one is string dot str dot strip, and then second one is remove punctuation, which we have already defined, and then str dot title. So, we would like to perform these three function based operations. So, in a sense we have created more structure where we are listing out the functional operations that we want to perform. Now, what is left in the clean strings function? So, in this function again we are creating an empty list result, and we are running a loop just like before. And now, for f in ops, so now we have two for loops. First for loop is to iterate over the strings. So, for each string we would like to operate something, we would like to perform something. Then second loop, each operation in the ops we would like to the list of operation we have created. So, we would like to iterate over that list, and then we are just going through applying those operations. You can see for each element x we are calling that function f x. So, in a iterative fashion we are calling each of those functions, and this is more reusable, more structures. So, this is more scalable, in the sense more generic kind of function. In some other scenario we would like to we would be required to perform another cleaning function, another cleaning operation, then we would just have to add that particular functional object in the clean ops list, and you can see the clean strings function we won't have to make any change. However, in the first approach that we had in the clean string functions we would have to make changes. However, in this we would have to make just add that particular function in the list of functions that we would like to perform. So, this is slightly more reusable, slightly more generic way of writing the same code block. So, let us run this, and now let us again have a look at the message string that we had. Now, you can see we are calling clean string functions. First argument is the message string, the second argument is clean ops, that means list of functions that we would like to apply to clean the string that we have in the first argument. So, if I run this, the same result is achieved as you can see. So, you can clearly notice the differences, in the sense the same function, same code lines, more or less similar thing, but just the way we organize the code, the second approach made it more usable, more generic in that sense. So, with that we would like to stop here, and we will continue our discussion on functions in the next lecture. Thank you.